Hi guys, Lever here from Bright Young Brains. So, today we have a surprise, if you will. This is a grade 10 paper, specifically from Reddam House in Waterfall. Now, this is a paper that I'm going through for one of the students that I tutor privately. But the reason why I'm also doing this is depending on what grade you are in, right? Grade 11, grade 12. I think this paper is going to be good practice for you to get an idea of how much you actually do understand. So the link to this paper is in the description. I suggest that you download it, go through it, try it out. I will also be doing this for the paper too. And best believe soon enough, I will also be going through a few grade 11 papers for the purposes of what I think it would be good practice for you, whether in matric or not. So this is a 2-hour paper. Now obviously you can definitely try to get an idea of how long you would take to go through this entire 2-hour paper that we are set to go through here. But anyways, without wasting any time, let us begin. So we have some formulas here. It says that we should factorize fully. So remember, anytime you're being asked to factorize, you want to take out a common factor. So here we can take out x as a common factor. If x is gone, we'll have x squared left, and then here minus 4. The only thing is, if you have to factorize fully, the big idea is this is the difference of two squares. Now, the difference of two squares means that you have something that's a square number, and you're subtracting something that is also a square number. Now, anytime you have the difference of two squares, right, this can be factorized by having two brackets where you basically have the square root of the first value over here, and then the square root of the second value over here. In the first bracket, you put a plus. In the second one, you put a minus. I mean, it doesn't matter which one is the plus, which one is the minus, as long as you just have plus or minus. That's the difference. That's the difference of two squares. What that means is if you were to multiply out these two brackets, they would return to what you would have in the beginning here. So in our situation, we can see x squared is a square number, 4 is a square number. So this, we have the difference of two squares, meaning we can have one bracket and then another bracket. Square root of x squared is just x. So you put x there and you put x there. Square root of 4 is a 2, so you put 2 there and a 2 there. And then one bracket gets a plus, one bracket gets a minus. That's how you're going to get your entire 3 marks for a question like this one. So let us keep things moving. So the next question is also asking us to factorize some more. Now, factorizing an expression like this one, we have a cubic, the difference of cubes, if you can put it that way. Now, when you factorize the difference of cubes, you also need to have a specific method. Now, this method is something that you can always remember. You will always need to have a small bracket and a big bracket. Now, this method is also showcased in the algebra course on our course website, of which the link to the online course is in the description. Now, the one thing I can safely say about the algebra course is that, funny enough, it is actually one of those courses that, depending on what grade you're in, you see Bright Young Brains, depending on what grade you're in, grade 10, 11, or grade 12, you will definitely be able to benefit from signing up for something like the algebra course. But anyways, what you'll learn is, if you're going to factorize the difference of cubes, you need to get the cube root of what you have here. So you start with the number. The cube root of 8 is a 2. The cube root of x cubed is an x. That's what you put here. The cube root of 1 is just a 1. That's what you put there. So in this small bracket, you put the cube root of this first one, you put the cube root of this second one, and then before we put whatever value goes here, let's just put in the rest of the numbers. In this longer bracket, or this bigger bracket rather, or this slightly more open space, you are going to need to put 3 terms. So the one on the far left here, it's always going to be this value squared, which in this case is 4x squared. On the far right, it's going to be this value squared, which is just a 1. In the middle, you're going to have these two multiplied by each other, right? So the 2x and the 1 just gives you a 2x. So when you've done this, all you need to keep in mind is whatever is in the middle here, or whatever you have originally, it's what goes there. And whatever is here, you always put the opposite over here. And then here, this is always a plus. You see, so here, always plus, always plus. This one, opposite, right, of main bracket. Your opposite of main. You see, and then this one here will always be identical to the main one. Identical to main. You see, the main bracket, the main expression is what I'm referring to. So don't forget things like that. You get it. So hence also this recording, because this is also to give you a mini rundown of, you know, all that work from the previous years that you probably forgot, but is still valid in your grade 12 mathematics. For 3 marks here, it says, you also need to factorize fully. Now, also you being able to factorize here, you need to be able to identify how this here and this here, there definitely is something that looks alike for these terms here. Now, you can see here we have like 2x minus 3. Here you have the 3 and then the 2x. So what you could actually do first off is, whichever way you want, you could either swap these two and take out a minus, or you can swap these two and take out a minus. It doesn't matter what you choose to do. So let's do what would normally maybe not be done, right? Let's swap these first ones here, the ones that we're seeing first here. So what's going to happen is if you swap these two first, right, you might end up with something like negative 3 plus 2x minus 2 and then 3 minus 2x. So the issue is they don't quite look alike as yet. They don't quite look identical, you see. So for them to look identical, we have to take out a negative in the first bracket. A negative has to be taken out as a common factor. So if you take out a negative, you're going to have 5x here. Now here you're going to have a positive 3, and then here you're going to have a negative 2x, you see. So that's the good news here. So with this being done, let's see. Now this first bracket, now this bracket here and this bracket here, right, they look identical. So you can take that out. You see 3 minus 2x, you can take that out. What's going to be left here is negative 5x minus 2. Negative 5x and then minus 2. See, there we go. This is what you have once you factorize. Now, knowing these kinds of things, it helps you to know how to factorize for other kinds of expressions. Even if it's like paper 2 work, being able to factorize is a valuable tool. So this would earn you 3 marks in a paper like this. Simplify, leaving all answers with positive exponents. So again, a basic law that is showcased here is that anything to the power of 0 is a 1. You see, anything to the power of 0 is 1. Something to boost your confidence. So here you can have 1 plus 1 over 4. That's just going to give you 2 over 4, which is just going to give you 1 over 2. Now, something like this, you have to be careful, because fortunately, because you're not adding or subtracting, the square does go for each of these individually. So what you also then need to do for yourself is to start off seeing this division symbol here. It's usually not something very comfortable to like be working with mathematically. So what you can do for yourself is you can just change this to a division line, meaning you'll be seeing there something like a to the power of 3 over 2, the whole thing squared. Now from here, you know that the square goes for the numerator, but if you have an exponent here to the power of an exponent, you multiply the exponent. So for the top, you're going to have a to the power of 6. At the bottom, 2 is to the power of 1. So the 1 times the 2 is going to give you 2 to the power of 2. And then here you obviously have a to the power of 6, the whole thing over f4. You cannot go any further from here. So you just leave it the way it is. You see. Next question, to understand, we still need to be, here we have to simplify, leaving our answers with positive exponents, okay? So here, if you're gonna simplify, right, you have to remember that the exponents, everything here, right, is to the power of this exponent, but they said you have to leave your answer with positive exponents. So for something like this, right, what you could do for yourself to help yourself is, remember, if you're going to simplify 8, you can write it to the power of this, but you need to find a way of like visualizing, or you need to find a way of seeing, you know, something that can be written out in like a simpler way. But 8, fortunately, you need to know that 8 can be written as 2 to the power of positive 3, right? Now let's leave this for now, and let's leave this for now, and just take things step by step. So the reason for doing what we've just done now is because now we can multiply each of these exponents with negative 2 over 3. Fortunately, you can even use your calculator to do that, you see. So 3 times this exponent is just going to give you a negative 2. Negative 3 times this exponent is just going to give you a 2. 12 times this exponent, what is it going to give you now? It's going to give you a negative 8. So the thing is, your exponents need to be positive, as they said. So anytime you have something that is a negative exponent, all you do is, right, you take it under the division line, because you have to remember the way it is now, right? There's a 1 down here, you know, logically speaking. So what you do is, anything with a negative exponent, you take it under that division line, meaning you're gonna have a squared left on its own there. Down here, you're gonna have 2. Now the exponent becomes positive. Down here, you're gonna have also b, but the exponent becomes a positive. See, there we go. Okay, so let's see. With all this being said, right, for 4 marks, let's see what they want us to do. The idea is, here we just have to be careful. Fortunately, it's 2 things being multiplied together, but they have the same exponent. So a situation like that, fortunately, you have to recognize that each base, the bases, you can multiply them together, and then the exponents, you can have it as like one big exponent for both of them. So for the top, you can have there 2 times the 3, everything to the power of x plus 3. The bottom here, we can just for now leave it the way it is, 3, and then x plus 2 as the exponent here. So the reason for doing this is, I mean, let's see, at the top, we can see we're going to have a 6 here. 2 times 3 is definitely a 6. So let's see that there. And then the bottom here, you may be thinking the 3, you may be thinking that the what you may call the 6, can we not write it as what you may call as 2 times 3 or something like that? We could, but it doesn't seem like it's necessary. Down here, we can leave what we have the way it is. We can just leave it the way it is. We don't have to worry about changing it. But let's see here, 3 and then 6 x plus 2 over there. Now the big idea is, you have to remember that if you are dividing, right, and your bases are the same, you can subtract the exponents. So let me put that in practice in very simple ways. The 6 here and this 6 here have the same base. So because you're multiplying down here and because you're dividing here, you have the liberty of writing the following. At the top, you can put the 6 with x plus 3, right? But then, because the bases are the same here, if you're dividing, right, you can subtract the exponents. So you can just say here minus x plus 2. At the bottom, you still just have your 3. So here you just have to be careful now, because here you're going to end up with like 6 x plus 3 minus x minus 2, right? The whole thing over 3. X cancels x here. Here you have 3 minus 2, which is just a 1. So there you go. The answer is just a 2. Now, a trick you can always use to double check if your answer was worked out correctly, if you're simplifying, is you can just choose a random value for x. Let's say like, I don't know, 5. Put it here, put it there in the calculator and see if your answer simplifies to 2. If it simplifies to 2, you know that you did the correct thing. If it does not simplify to 2, then you know that there's something wrong. Out of nowhere, I'm just looking at this and I'm like, wait, we can just have here a squared. 2 squared is a 4, and then b here, power of 8 can just be there. I don't know how I just ended up thinking of that. But anyways, moving on to question number 2.
As of this recording, the All Access Pass, which allows you to access everything on the website, is currently on sale. The sale will give you access to the online courses for a total of 60 days. Now, the All Access Pass includes the entire syllabus, everything for paper 1, everything for paper 2. You have video lessons that are preloaded on the website, meaning that you'll be able to go through all these video lessons at your own pace, at your own time, without worrying about anyone necessarily scheduling any sessions. Now, the link in the description will take you to the course website where you'll be able to make a purchase of this bundle. The sale is ongoing between the 23rd of October until the 7th of November. Depending on when you're watching this, I suggest that you hop onto the course website and make a purchase. You can purchase directly on the website using a credit card, debit card, or you can make a purchase via the EFT details that are provided on the website. As a reference, you should put in your name and your surname and send the proof of payment to the email address listed on the screen. For more queries, questions, you can always just contact us via WhatsApp. If you would like to find out more information about Bright Young Brains, you can always just Google us and you will be able to find more information regarding what it is that you would want to find out. Depending on where you're currently residing, you can always just contact us via the contact details that you see on the screen.
Solving for x. Here, you don't want to make the mistake of making each bracket equal to -3. That does not make sense. The only reason why we make each bracket equal to 0 when the question looks like this is because when you're multiplying two things, one of them could potentially be a 0, or both of them could potentially be a 0. That's why in a situation like, let's say, if you had x plus 1 here and x minus 3, here you can easily just say each bracket equal to 0 and then carry on. But then for a situation like this one, you cannot. You first have to FOIL out the brackets. You have to multiply it out first and then deal with the -3 afterwards. So here you're going to say x times x, which is x squared, x times -3, -3x. 1 times x is positive x. 1 times -3 is -3. And then you have equal to -3 here. The -3's will cancel out when they move to the same side. So you now have here, whoa, error. No, it looks fine. X squared here, -3 plus 1, give you -2. And then now you can take out x as a common factor, x minus 2 equal to 0. Now, because you're factorized, you can make each of these equal to 0. Because you're saying something times something could be a 0, or this could times that could be result in a 0 if this is a 0. So here, this could potentially be a 0 if x is a 2. This could be a 0 if x is a 0. So these are your two answers for x. So 3-mark question, nothing crazy. Solving for x here, we obviously need to deal with the bases and the exponents. So fortunately, each of these bases can be written in another way. The 8, we can write it as 2 to the power of 3, but the whole thing has to be to the power of x. 4, we can write it as 2 to the power of 2, but the whole thing is to the power of x minus 2. And then 3 times x is 3x as the exponent. And then 2 times this here, right? We're going to have 2 multiply there. We're going to have like 2x. Multiply there. We're going to have like 4 equal to 1. So remember, the rule still stands. If your bases are the same and you're multiplying, you add the exponents. So here you can have 2, 3 to the power of x plus 2x minus 4 equal to 1. So that is all nice. Obviously here, these are like terms. So you can have 5x minus 4 equal to 1. Fortunately here, what you need to do is when you work with an equation and you're dealing with exponents, you normally want to make sure that both sides of your equation have the same base. Now, for you to have a base of 2 and you're dealing with 1, you can just remember that anything to the power of 0 is a 1. So the reason why you would want to have a base of 2 is because as long as your base looks like what you have on the left-hand side, the next step here, you can drop the bases, meaning you'll have 5x minus 4 equal to 0. The minus 4 goes to the other side. It's going to be a plus 4. And then here, you're going to divide both sides by f5. So here you can have 5x, right, over 5. And the 4 here over 5. And then this cancels this. You can have your x is equal to 4 over 5, like that. That's going to be your answer. Now remember, because of questions like these, right, anytime you are going to be solving for x, you need to give yourself the opportunity to test your answer by just throwing it into the original equation. You can just take your calculator, you throw it into the original equation, wherever x is, you see if the equation balances out. If the equation does balance, your answer is right. If the equation does not balance, there's something wrong with the answer. But anyways, this does balance out. So let's keep moving forward. Question number C. We have C here, question 2, solving for x. So again, here you would want to spot that these are like terms. So we can take that out as a common factor. 3 to the power of x. And then here you have 1. No. Before you even do that, let's try and visualize properly what's going on here. So this is 3 to the power of x minus. This you can write it separately. 3 to the power of x and then 3 to the power of negative 1. The reason for doing this is because if your bases are the same, right, you add the exponent. So when it's like this, it can be written like that. When it's like this, it can be written like this. So let's take out 3 to the power of x as a common factor. If you take this out and you take that out, you're going to have 1 here and then 3 to the power of negative 1. Now, all this being said, right, this is 1 minus a third. 1 minus a third is 2/3. You see, or rather, you would have just done it in your calculator. So you don't even need to worry about anything. And in the name of using your calculator, be comfortable using a calculator when you deal with fractions, because you want to solve for x, right? So you can divide both sides by the 2 over 3. That cancels out. Here you also divide by 2 over 3. Just use your calculator. In your calculator, what's going to happen is you are going to get here 100. And I feel like I'm busy asking myself, yo, bro, why are you yawning, bro? Like, yo, come on, man. Come on. So we're going to have here 162 over 2, right? This is equal to 3 to the power of x. And this here, we know that it is equal to 81. The reason why this is good news is because we know that 3 to the power of, is it to the power of 3? No, I think 3 to the power of 4 is what gives us 81, because 3 times 3 is 9, 9 times 3 is 27, 27 times 3. If the maths is not off, it definitely does give us 81. So here we can say this is now going to give us 3 to the power of x. This we can write it as 3 to the power of 4. So the only way the two sides can be equal is if the value of x is a 4 here. You see, there you go. And we said always test out your answers. Put a 4 there. put a 4 there, 0 will give you 54, and it will. That will give you 4 marks. D here is saying illustrate your answer on a number line. Before you can illustrate your answer on a number line here, you need to be careful. You need to make sure that you isolate X. So isolating X here, you have to work with everything around X, one by one. The one thing to start with here is the minus 3. So what you do is to get rid of a minus 3, you have to add 3 everywhere. So you're going to add 3 here, and then you're going to add 3 here, and then you're going to add 3 here. So doing that, it's -1, right, plus the 3. You're going to get a 2. And then here, if you add a 3, right, obviously this cancels out. So you're going to have 2x here, right? And then here, 27 plus 3 is a 30. So all this being done, you can divide by 2 everywhere. Divide by 2, divide by 2, divide by 2. This is going to give you a 1. And then this here is going to give you an x. This here is going to give you a 15. So we might as well draw our number line here. So the idea behind drawing our number line is that all this is telling us is that our sets of answers, right, for x, these are numbers that are bigger or equal to 1, but those numbers are smaller than 15. So in a situation like that, let's just draw a number line, right? Let's even maybe put here 1 or 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yo, I guess we're gonna have to start from 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the idea is, if your numbers are between 1 and 15, but it's saying here x is bigger or equal to 1 and x is smaller than 0. So if x is bigger than or equal to 1, it means that at 1, you have to put like a closed dot there to show that you're starting, your x values are numbers that are bigger than 1, but they can also be equal to 1 up until 15. But here you put an open circle because you do not include the 15, because your values have to be smaller than 15. And then you just join these two lines here, or you just join those 2 dots with a ruler, obviously, if you have one. But in my case, let's see if I can even draw a straight line here and it will allow. Let's see. Ooh, yes, it will. What a wow. So quite interesting, but is okay, we'll take it. So yeah, you're just gonna have to join your 2 sets of dots here with a line in the middle. See, if you can do that, you'll be good. Whoa, look at me wasting time trying to join these 2. Nope, it was worth it. Moving on to question number 3. Question 3, it says here, you buy a computer using a hire purchase agreement from a computer dealership at your local mall. Now, the key thing here is, if you're gonna buy anything on hire purchase, it means that you like put down a deposit and then you pay the rest afterwards, but you still take the item. But it says here, the computer's cash price is 22,500. And then they then are also saying here that you deposit 15%, and then they said here the simple interest is 24% per annum on whatever the balance is, meaning whatever is left after you pay the 15%. And then they also say here, the balance is to be paid over a period of 2 years. Okay, so all this seems fine, nothing crazy. They said here, you take the deal, you need to calculate the required deposit. So the required deposit is 15%. So let's say here, the required deposit is 15% of the 22,500. So when you need to write out any question, right, or when you need to answer an equation, always write it out mathematically. And then after writing it out mathematically, you want to then translate, you want to write it out in words based on what they're asking, and then you translate it to mathematical symbols. So fortunately here, for something like 15%, you could write it as 15 over 100. If you want to write it as percentage, you can do that. Just make sure that when you be putting stuff in your calculator, you write the percentage symbol visibly. So here you can say, this is 15%. No, 15 over 100. Off means times. Then you have 22,000 here, 500, right? In your calculator, let's see what this is going to give us. See, so in our calculator, this is just going to give us 3,375. 3,375. Nothing crazy, nothing major. That's easy, 2 marks. The next question, however, says we need to calculate the total amount including interest you will need to repay. So they said whatever we are owing, right? They're going to add simple interest to it, 24% over a period of 2 years. So the 24% is compounded annually. So this is just a question where we have to use the the simple interest formula, where we know that the simple interest formula is just A, let's go to P, 1 plus I multiplied by N. Now P is the amount that you're owing. You see, so the amount that you're owing is going to be the 25, is going to be the value of the computer minus what you paid. You see, so the value of the computer, if you subtract what you paid, we're going to get here, let's see, going to get here 19,125. So the value of P, right, is 19,125. 1 plus the interest is 24%, you see. So you can put here 24 over 100. And then you have to be careful here, because since you're multiplying, right, you want to make sure that this is over 2 years also. So you could make sure that you put brackets here, to make sure that this is done first in your calculator even. So all this done, let's see what that gives us in the calculator. It's giving us the 28,305. So you can see why this is like a terrible deal, because it is what it is, but it's just terrible because in the space of 2 years, it's paying more than what the thing actually cost. And the interest rate is way too high also, but it is what it is. Now they're asking us to calculate the monthly repayments. So it's going to be 28,305 divided by 24, because this is the amount you owe. You have to pay it over 24 months, you see. So the amount you owe divided by what you pay over a period of 2 years, let's see what you get here. This amount divided by 24, what are we getting here? We're getting 1,179.38. Let's move on to question 4. Question number 4. Here we are. It says the weather forecast for the area for the coming weekend predicts a 30% chance of rain for Saturday and a 40% chance of rain for Sunday. What is the probability that it will rain on Saturday or Sunday, but not both? Oh, but not both. Okay, what is the probability that it will rain on Saturday or Sunday, but not both? Okay, I think the but not both part is important. So let's see here. They say you may use a tree diagram to assist you. So when you're going to use a tree diagram, remember you're representing 2 days, and in each of those 2 days, there are 2 possible scenarios. So what you do is you start at Saturday, right? You start at Saturday. So starting at Saturday, you know that it's either gonna rain or it's not gonna rain. You see, let's write here Saturday. So if it does rain on the Saturday, on the Sunday, it could rain or it could not rain. However, if it does not rain on the Saturday, it means that on the Sunday, it might rain or it might not rain. Those are all the outcomes here. Now, before we put in those probabilities, you can just see here, this is raining and raining before. That's RR. This is not raining, raining before. This is raining, not raining before. This is not raining and not raining. The idea is your probabilities now. They said the chances of it, they said here, the weather forecast predicts that there's a 30% chance of rain on Saturday. So raining on Saturday, there's a 30% chance, meaning not raining, there's a 70% chance. So on the Sunday, they say there's a 40% chance it will rain on the Sunday, right? So on the Sunday, raining, there's 40%, meaning not raining, there's 60% chance. Same here, raining, there's a 40% chance for the Sunday or 60% not raining. So what you need to do for yourself is your outcomes here will always be equal to your probabilities multiplied by each other, you see. So for example, raining and raining is the 40% times the 30%. And then you do the same for all the others here. You see, not raining and then raining, you see. These are your different probabilities. These are the answers that, and then here, not raining multiplied by raining. And then here you have here, not raining multiplied by raining. There you go. Whew. So these are the calculations that we'll need to perform depending on the questions. But the question is saying, what is the probability that it will rain on Saturday or Sunday, but not both? So the probability of raining on Saturday or Sunday, but not both, it's these two here. You see, because this is raining on both days. But then the probability that it will rain on the Saturday or the Sunday, but not both, these are the two probabilities. So you add them up, you see. So it's going to be this probability here plus this probability. You just put that in your calculator. So you're going to put your 30% times the 60 there in your calculator. And then you're going to add the 70% there multiplied by the 40%. So let's see what that gives us in our calculator. So in our calculator, let's see what it is giving us there. Well, one way or the other. So in our calculator, this is giving us 0.46, which is a-okay. Nothing bad there. Everything seems to be okay. Let's move on. It says here, given the following sets, they say it here, all C block MSA. Okay, so U is representing everyone in block C. H is representing the boys who play hockey. S is representing the boys who swim. So for 1 mark, they're asking, explain why these events are not mutually exclusive. So the reason why these events are not mutually exclusive. Remember, mutually exclusive events, what it says is the probability of one thing happening and another thing happening. The probability of them happening at the same time is a 0. That's for mutually exclusive events. But in this case, the reason why they are not mutually exclusive events, it's because these two events could potentially happen at the same time. A person can play hockey and swim at the same time. It is possible. See? So let's say here, because it is possible for a pupil to play hockey and swim. You see, so that probability would not be a zero, meaning you would not have mutually exclusive events, or you're not dealing with mutually exclusive events. They say here, describe the following in words. So this is saying the union. This is saying where the boys who play hockey. This is saying boys who play hockey and boys who swim. Boys who play hockey and also play boys who play hockey or also swim, or boys who play hockey and also swim. That's the simple definition there, hence just the 1 mark question. The NH here is literally telling you the number of, N here means number of. So this is saying the number of boys who play hockey. If it was, let's say, if they wanted to say not, if they wanted to say not the number of boys that, or if they wanted to say not the boys that play hockey, they'd put an H with an accent there. This is what not means, but then the N in front here means number of. So here this is number of boys that play hockey. There you go. That's the way we like it. So since we now know this is the number of boys that play hockey, it's all good. Let's move on to the next question. So here we are, question number 5. It's a functions and graphs question. So obviously, out of curiosity, just let me know what grade you are as you're going through this paper. And also just whether you think it's a good idea to have, other grades on this channel so that you can basically use those as a way for you to practice and boost your confidence. But anyways, let's see. Sketch the following functions on the set of x's provided. It says here, show all intercepts with the axis. You have to show any turning points, any axis of symmetry, and asymptotes where applicable for 5 marks. So you see, this is how you need to know your theory. You see, your basic theory comes all the way from grade 10. This is an exponential graph. And in grade 10, you learned that an exponential graph has an asymptote. See, asymptote. This is your asymptote. It's the line your graph does not touch. So if you're going to sketch your exponential graph, the first thing you're going to point out is the line your graph will not touch. You can even label it. This is the equation. Y is equal to positive 1. Now, what you know is you can also then get your x-intercept by making y a 0. To make y a 0 here, 2 to the power of x plus 1, the 1 goes over. The issue is you cannot have any y-intercept. So because there's nothing to the power of 2 to the power of, there's nothing that you can have here that will give you a negative 1. So you now know your graph is not going anywhere down. You see, it does not have a y. Wait a minute. Bro. Hold up. Yeah, you now know it does not go anywhere down because it does not have a y value of 0. So you know your graph can only go upwards. So now you can get an x-intercept. To get an x-intercept, you can get a y-intercept. So to get a y-intercept, you make x a 0. So here, x is going to be a 0. 1 plus 1 is a 2. Positive 2 over here. Now, the big idea is your exponential graph, right, looks like this. Going upwards. The reason you know that is, as your numbers for x are increasing, this value is getting bigger and bigger and bigger and bigger. And then plus 1, you see, it will just get bigger and bigger and bigger, going wherever it is going to be going. That's your graph of f of x. So we can even label it f of x here. The graph of G is a hyperbola. So drawing our hyperbola, you need to know that a hyperbola has two asymptotes, but the way it is laid out here, we can see that the first asymptote, oh no, this is a straight line graph. The reason why I thought the x was down here, this is a straight line graph. The reason why this is a straight line graph is because there's a 1 here, you see. So 1/2 there, you just have a half as the gradient of G. So when you're looking at the graph of G, you should be seeing there a half x plus 2. So clearly what this is telling you is, you have to know your theory, you see. Your gradient is telling your line has a positive gradient. This is telling you your line has a y-intercept of positive 2. So it cuts the y-axis at 2. I always say with a straight line graph, just put your y-intercept and put your x-intercept and then just join them. So getting an x-intercept, you have to make y as 0. So here, if you make y as 0, you have here a half plus 2, and then you have here negative 2 with the half there. And here, remember, don't treat a fraction as though it's different from any other number. It's in front of x here, so to get rid of it, you divide by the half, and then you do the same here. You see, negative 2 divided by half is going to give you a negative 4. So it means that your x-intercept is negative 4, which makes sense because, I mean, your graph does have a low gradient of a half. So these two dots, they obviously need to join each other. That's going to be your straight line there. If you were going to sketch it, you see, this is your straight line. You can see it's really not anything that is like difficult in any way. We just did what we normally did. Oh, this is just normal. It's a straightforward question, nothing crazy, nothing major. So here you may want to put these arrows, show that the graph extends, and then labeling it, you can just label it there, g of x. There we go. So let's keep the ball rolling. Let's keep things moving, because why not? So with everything being said here, right, let's move on to the other basic questions that you can see here, were also assessed in grade 10. So here they're asking for the range f. F is an exponential graph. Now, when they ask for the range of any graph, excuse me, and when they ask for the range of any graph, they will be asking you which y values does that graph go to. So our graph of our exponential graph here, or rather our exponential graph, it goes, if you can see how it is behaving, the asymptote is a positive 1, right? Now, it means that that's the first y value the graph does not touch. It does not touch positive 1 and anything below positive 1. The only y values that this graph has is everything above positive 1. So when they ask for the range of f, right, you're going to have to say here, your y values are bigger than positive 1. Your y values are bigger than positive 1. So that's that for that range question. C says, give the equation of k if k is a reflection of f in the x-axis, no, in the y-axis. Let's say that again. Give the equation of k if k is a reflection of f in the y-axis. So if you reflect a graph about the y-axis, you see you're changing your x values from positive x values to negative x values, because you're reflecting it about the y-axis, you see. So your image would even look something like that. This is what the graph of of k would look like. So when you have to get an equation of a graph that is then reflected about the y-axis, what you do is whatever equation they are talking about, the original one, wherever x is, you have to put a negative there. So the equation of k of x is equal to 2 to the power of negative x plus 1. There we go. That's also easy information you need to have learned or remembered all the way from grade 10. Find the equation of H if H is perpendicular to G, passing through the origin. So we need to find the equation of H, right? H is perpendicular to G. So remember, what we know about perpendicular lines is that their gradients multiplied together give you a -1. So them talking about H here, all the information about H, we're gonna need to get it from G. Fortunately, they told us that it passes through the origin. So getting the equation is really not going to be a hassle, as it shouldn't. You see, it shouldn't be a hassle. So this being said, let's get the equation of G. The equation of G, what we know is the gradient of G is a half. So a half multiplied by the gradient of the second line should give us a -1. If you divide by half on both sides, we're going to get the m is equal to -2. Here we go. That's the gradient of H. The y-intercept of H is just a 0 because it passes through the origin. So the equation of H, I'm going to say h of x is equal to -2x, because your gradient is a -2, your y-intercept is a 0. Now they said, for which values of x will h of x be equal to g of x? So when they're asking you for where two graphs meet, you have to obviously make the two equations equal, as they have done here. You can clearly see your equation of h needs to be correct. Otherwise, you lose double the marks. The equation of g, we have the equation of, oh, it's +2. Oops. Oopsie. Anyways, let's solve for x here. Solving for x, we can just take the half x, we can put it together with the 2x there, becomes a plus. The 2, we can take it over, it becomes a minus. 2 plus a half is going to give you 2.5, but as a fraction, it's 5/2. And remember, we said fractions, you just treat them the same way you always treat any other number. So the way this looks now, you can just divide here by 5/2, divide here by 5/2 also. There you go. So what's going to happen here is you have the -5. There we go. That's going to be your answer for x. They're going to meet where the x value is a -5. Logically speaking, it doesn't almost want to make sense, because if they're saying here it passes through the origin, let's see, half plus 2x -2 has 0 there. They say they're perpendicular. If they're perpendicular, they should not meet somewhere there. That's too much. Yeah, what is going on here? Determine the, yeah, I think it does look like I made a mistake somewhere, obviously. So in a situation like this one, we obviously want to just backtrack a bit and then just find the error, you see, because if you don't backtrack, there it is, I found the error. There's the, what you may call, there's the culprit, the half here, because these here, I don't know where I got, so I took this over, became a plus, and then I took the other one. So 2 plus a half is 2.5. Yes. And then, oh yeah, that's my mistake. The answer here is not a 5, bro. This is what happens when you do mental maths. It's -4/5. Yeah, that makes sense, because they're likely to touch before the 1. You see, or rather before the -1. So if they touch somewhere here, the x value would be like negative something before the -1. So this answer is fine. Let's move on to question number 6.
As of this recording, the all access pass, which allows you to access everything on the website, is currently on sale. The sale will give you access to the online courses for a total of 60 days. Now, the All Access Pass includes the entire syllabus, everything for paper 1, everything for paper 2. You have video lessons that are preloaded on the website, meaning that you'll be able to go through all these video lessons at your own pace, at your own time, without worrying about anyone necessarily scheduling any sessions. Now, the link in the description will take you to the course website where you'll be able to make a purchase of this bundle. The sale is ongoing between the 23rd of October until the 7th of November. Depending on when you're watching this, I suggest that you hop onto the course website and make a purchase. You can purchase directly on the website using a credit card, debit card, or you can make a purchase via the EFT details that are provided on the website. As a reference, you should put in your name and your surname and send the proof of payment to the email address listed on the screen. For more queries, questions, you can always just contact us via WhatsApp. If you would like to find out more information about Bright Young Brains, you can always just Google us and you will be able to find more information regarding what it is that you would want to find out. Depending on where you're currently residing, you can always just contact us via the contact details that you see on the screen.
Question 6. It's a number pattern question. Now it says here, the first 3 figures of a pattern comprising dots and sticks are shown below. So they said here, figure number 1 has how many sticks? 1, 2, 3, 4, 5, 6, 7. Here it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then here it is dots and sticks. Let's just write the dots on top, the sticks at the bottom. So the number of dots here, 1, 2, 3, 4, 5, 6. Sticks, we have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Whoa, awkward. This is like 8 dots. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here, 1, 2, 3, 4, 5. Wait, the dots first, so it's like 10. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There we go. A says write down the number of dots and the number of sticks in the fourth one. So we have to just follow the trend here. You see, on top it's like counting in twos, going from 6, 6, 8, 10. So the next one is going to be a 12. The bottom, 7 to 10, that's plus 3. To 13, that's plus 3. And then the next one is going to have 16. So let's say here dots equals 12, sticks equals 16. There we go. We're gonna have 16 sticks. So for 2 marks, that's easy. B says determine expressions in terms of n for each of the number of dots and the number of sticks in the nth figure. So when they speak of something like this, they just want you to give the formula for you to be able to work out the specific number of dots or the specific number of sticks for any figure. So what you want to recognize is what you have here, right? The dots and the sticks. You have what you call an arithmetic sequence, you see? Arithmetic sequence. Now, the idea with any arithmetic sequence is that if you're gonna need to find its formula, you literally just need 2 things, which is the first term, and you need to find the common difference. If you know that, you will always be able to use the following structure or the following template to get your formula. Your template looks like this. Tn is always a plus n minus 1 d. Now the idea is a is your first term. Let's put your first term. And then d is your common difference. difference. And then, as long as you have these two, you'll be good to go. For example, Tn, right? Stays Tn. A is the first term. So we're doing the dots first. In the dots, the first term is 6. The common difference is 2. So we put a 6 here, put a 2 here. Here you can simplify, right? 2 times n is like 2n. 2 times negative is like negative 2. You have 2n here. 6 minus 2, right, is a plus 4. There you go. And then let's do the other one now. That's for the dots. For the sticks, same idea, same template. But then your first term for the sticks is 7. Your difference is 3. So here, first term 7, difference is 3. If I simplify, the 3 multiplies inside again, and then you have here 3n, right? 7 minus 3 gives you a plus 4. There you go. There you go. Now, this is going to give you 4 marks. You have 2 formulas, and one is for the sticks, one is for the dots. Let's move on. 7, we're factorizing fully again. Interesting. This is section B. So if you're going to factorize fully here, it means that you have to be careful, obviously. Now, multiplying inside doesn't seem like it's a wise thing to do. Now, the one thing that you could be thinking to yourself here is, how do we factorize something that looks like there is no ways of factorizing? So in a situation like that, obviously, you have to remember that where there is fuel, where there's smoke, rather, there's definitely fire. So you could be thinking to yourself, but multiplying inside may not seem like a good idea, but it seems like the only thing to do. So you will do it. 3 to the power m to the power of 3 times m to the power of 3. That's m to the power of 6. If you multiply again, you can have 4m to the power of 3. The minus 5 is still just there. What I'm about to showcase is something very interesting. Now, you want to pay attention because this portion of the work is obviously why this question is out of 4. When you're looking at something like this, you want to realize that what you have here is a situation where if you're going to factorize, you have to visualize this as a trinomial. This is what I mean. If you had, let's say, k squared, right, plus 4k, and you had minus 5. To factorize this, what you would do is you would have 2 brackets, and you'd say factors of 5 that give a 4. It's just 5 and 1. And then you'd say, to get a plus 4, you would need to say plus 5 minus 1. And then you'd put a k here, you'd put a k here, you'd be done. This same way of thinking is what you want to do here. The only thing is you want to recognize that the m to the power of 3 is something that you can bundle up and have like there and like there. What I mean is the m to the power of 6, you may want to write this as m to the power of 3, right? Squared. And then the 4m to the power of 3, you can just leave it the way it is. Because the m to the power of 3, this, you want to see it as this k over there, you see? This thing here to the power of 3 is there, and it's also there again. So if you're now going to factorize, you can use the same logic. You can just say, okay, we're going to have 2 brackets that look like this. Factors of 5 that give a 4. It's just 5 and 1. To get a plus 4, you have to say plus 5 and minus 1. Whatever this is, you put that there. Whatever this is also. And whatever this m to the power of 3 is, you put that there and you put it over there also. And then you would have factorized. You see, this is a 4-mark question. So the K method is powerful. Moving on, it says, simplify leaving your answer with positive exponents. So if you're going to leave with positive exponents, you have to be careful. The top part, you can actually just try and see that for what it is. The top part, remember, this here can be written as a fraction. So at the top, you can have 1 over 1 minus 1 over a. Then down here, you just have your 1 minus a. So what happened at the top here is that a to the power of negative 1, right, can easily be written as 1 over a. Because remember, we're saying anything with a negative exponent, you have to take it lower. You have to take it down to whatever it is. So anything like a to the power of negative 1, automatically it has a 1 down there automatically. So when you will take it under this negative 1, there's a 1 that remains up here. You see, there's 1 here, a to the power of 1, and you're done. So in our situation here, that's what happened. You see, we did that. But because this is a fraction now, this also has to be a fraction. So for doing this, the reason for doing this is we're just trying to simplify as we know we are supposed to. So here we can deal with the top. Getting an LCD at the top, we're going to have times by a over a. You're going to have the a times 1, right, which is a. Since your denominator will be the same, you can just put the a there, minus 1. And now the whole thing over 1 minus a. So one thing I normally do is, if you see that there are too many division lines, change one of them to a division symbol so that you can carry on and see what happens. So here we can have here a minus 1 over a, right? The whole thing divided by 1 minus a. So this you can put it over 1. Now, with that being said, we can flip this over, right? So it's like a minus 1, flip this over, you're going to have 1 over 1 minus a. So your laws will tell you that the top times the top is going to give you a minus 1. The bottom times the bottom is going to give you a, and then 1 minus a. So these two here, they look like you can easily cancel them out if you at least have the signs looking alike. So it looks like you can take out a negative at the top and you can swap them around, you see. If you take out a negative at the top and you swap them around, you have this now. At the bottom, you have something identical to cancel with, you see. And then here, this just cancels that. You have negative 1 over a, which is just negative 1 over a. There you go. Your answer has positive exponents. Now, this is just a 3-mark question, but the logic is just don't rush. You see, just don't rush. What do you say? Don't run. Let's move on. C says, let me solve for x again. Solving for x, here you have to be careful because this, you can actually just leave it the way it is, right? And do the following. So here you can take the 4 to the other side. The reason for doing that is to get rid of the square there, you have to square root. But before you can square root, you have to make sure that what you're square rooting is like one thing on its own that has the square, you see. Because we cannot get rid of the square root at this step here by square rooting the whole thing, it won't work. But here we can square root this and we can square root this. You just have to be careful when you do this, because the moment you do this, you have to put a plus or a minus for your answer so that you can end up with 2 different answers for x. You firstly work with where you're dealing with a +2, and then you then work with where you're dealing with a -2. You see. So doing that, you're going to have here 2 minus 1 is a 1. And then 2, if you divide by 2 on both sides, you're going to have x is a half. Here, the 1 goes to the right. So it's -2 minus 1. So it's like -3. And then you're going to divide by 2 on both sides. Divide by 2, divide by 2. You're going to have your x is equal to -3 over 2. These are your 2 answers for x. They're both valid. They're both okay. You keep things moving. The next question here, you see here, these are slightly higher order questions. But it's okay. We're just taking things nice and slow. So a situation like this one requires you to obviously think outside the box. So thinking outside the box, you don't want to panic, obviously. Now, the idea is when you bump into questions like these and you like don't have an idea what to do, the best you can do for yourself is move on. Go to other questions within your question paper and then come back. So here, obviously don't overthink it like we said. So just start small. Normally when you're dealing with exponents, right, where your variable is an exponent, try to make sure that you don't have too many things around it, especially like another term, like here, the -8. Let's take the -8 to the other side. So if you take the -8 to the other side, it becomes a +8. Now, the one thing that you also want to keep in mind is when you're going to do maths, the more often you do it, there are certain things that will automatically at least jump into your head to give you ideas. So this is what I mean, right? You know that anytime you're dealing with exponents, you need to at least have bases that look alike. That's one thing that you know. You need to have bases that look alike. Now, a half here and 8 here, the only way you can have bases that look alike is if this is like 2 to the power of -1, and this is 2 to the power of 3. We all know that 2 to the power of -1 is a half. This is something you should know. The more math you do, the more you always just see that 2 to the power of -1/2 is a half. I mean, 2 to the power of -1 is a half. What you also do need to know is that 8 is just the same as 2 to the power of 3, you see. So that's your first step. You can put your 2 to the power of -1 with your exponent there. Here you can put 2 to the power of 3. Because with your exponents now, you can see here negative times this whole thing here. What are you going to have? You're going to have here 2 with a -1. And then here, positive x squared. Right? So here it's -1 squared 2. Here this is 2 to the power of 3. So your bases now, they are the same. So now you can drop them. -1 plus x squared equal to 3. Since you're solving for x, the negative can go over. It becomes a plus now because 3 plus 1 is 4. And then you can square root both sides. Square root this side, you have your 2 answers for x over there. So you see, think outside the box and don't panic. So let's move on to D. Moving on to something like D, right? We have to keep things nice and slow, as we said. So always look out for things that stand out. Like here, they're saying 2 to the power of y is p. Here you can see there's 2 to the power of y technically. And then also here, 2 to the power of y as well. Then they said write this in terms of p for only 3 marks. You want to recognize that anytime you see that you have an exponent, right? An exponent like this one, 2 times y, can be written as the y first and the whole thing to the power of 2. What I mean is this 2 here with 2y, you can write it like 2 to the power of y, the whole thing squared, because the 2 times the y is still just 2y. Here, it's just 2 to the power of y. And then because it's 2 to the power of y plus 1, it means this can be written like this. You see, because your base is the same, so you can add the exponents. That's how they ended up with this. So when you've done it like this, you can visibly see that this is the p that they're talking about. This is also p that they're talking about. So if they're gonna say 2 to the power of y is equal to p, and they give you this and they say write in terms of p, what you want to do first off is you want to restructure your question so that you can easily see the 2y, and then you can just drop a p there. You see, this is like p squared. There's also like 2 times p and then -8. There you go. There you go. Now you keep moving. It now says now solve for y. If you're gonna solve for y, don't start here. Start here, because remember, this is just like how this method works, right? You wanna do something that will help you break down or factorize. Once you do that, it'll be easier to work with your question. So in our example, since we have written that 2 to the power of y as p, if you're going to solve this equation, all you already know is you're better off solving this equation first after making it equal to 0. And then, let me put it this way. You can say here, let 2 to the power of y equal to p. Okay, whatever variable you want. What you have here is p squared, right? Minus 2p minus 8 equal to 0. Now here you have to factorize. So factorizing, remember, you now need factors of 8 that give you a 2. So you can think of factors of 8. Let's write them down. Factors of 8, you have 8 and 1. That does not give you a 2. You have 2 and 4. That does give you a 2. You have 4 and 4. That does not give you a 2. So only 2 and 4 work to get a 2. So because those work, right, what you're going to do is, this is p here. This is p. Factors of 8 that give a 2. It's a 4 and a 2. To get a minus 2, you have to say negative 4 plus 2. You see, now this is obviously equal to 0. So now, because each bracket here is equal to 0, you're going to say p minus 4 equal to 0, or p plus 2 equal to 0. Getting a value of p here, p is going to be a 4. The other one, p is going to be a negative 2. So all things considered, right? All things considered, now you have gotten a value for p. So obviously what you can now just do is, you know that p is equal to 2y. So you can solve for y. You know that p is equal to 2 to the power of y. So here you can also just solve for y. This one cannot go anywhere because there's no value of y that would give you a negative 2 as a result. This one, you already know that 4 is written is the same as 2 to the power of 2. So your y value here is equal to 2. There you go. And now you'll get your 4 marks. Let's keep moving forward. E here says, for 3 marks, find the value of b if 3 is a solution of the equation. So if 3 is a solution to the equation, what that means is wherever x is, you have to put a 3 there, a 3 there, a 3 there, and a 3 there. And then we have to just solve for b. That's why it's just a 3-mark question. So doing that, we're going to put the 3 plus 2 over 3 minus 1. And then we're going to put here b minus 3, 2 times 3. And then 2 with the third. I mean, we may want to write that as a mixed fraction. So 2 times 3 is 6, plus 1 is 7. There we go. Simplifying here, 5 over 2, b minus 3 is 6 here, 7 over 3. So let's see what now. So here, obviously, there's really nothing to worry about. Let's take the numbers to one side first. 7 over 3, you're going to minus the 5 over 2. Now, obviously, you can just use your calculator for this one. There's really no need to think that there's anything fancy here. So in this situation, obviously, let's see, 7 over 3 minus that. Well, I'll just put everything in the calculator once. You see, let's just times by 6 here, times by 6. So you're gonna have 6 here, 7 over 3 minus this thing here, you have b minus 3. The minus 3 goes to the other side, and then you're just gonna put all this in the calculator at once. You see, that's what it gives us. In the calculator, all this is giving us a 4. and then you get your answer. So you see, there's a grade 10 paper. If you can see that it's a bit difficult, now you see the method to the madness behind why I'm showcasing these lower grade papers, so that you can see that basics are important and you need to cater for that while you're still in grade 10 now, or whatever grade you are. Basics are important. Let's move on. It says solve for x and y simultaneously. So for 4 marks here, if you're going to solve for solve for x and y simultaneously, you need to be careful. You being careful, this is what I mean. You need to keep in mind that don't just rush into answering these kinds of questions. If you look at it and it upsets you a little bit and it's sort of like affecting your mood, the best thing you can do is move on with the rest of the paper and then come back to the question. So this particular question, if you're going to solve for x and y simultaneously, what you normally have to do, or what you 99.99% of the time have to do, is you need to isolate one of the variables in one of the equations and then throw it into the other one. So in this equation here, we can isolate y. We can take the y over to the other side, and we can take the 3 over to the other side. So whatever y is, we know it is equal to 2x minus 3. So now here we can put 2x minus 3 where y is. So with doing that, right, let's see what we're going to have. Let's see, 2x minus 3, right? So let's put here 2 to the power of x plus, we're going to say here 2x minus 3, right? 2x minus 3, 2 to the power of 2x plus 4. There we go. That's the way we like it. So everything here seems good. We can just simplify some more. 2 plus 1 is 3. So this is like 3x minus 3. And then, what is this now? 2 with 2x plus 4. Now here you can clearly see your bases are the same, so you can drop them and work with exponents. So what you have here, you can take the 3x and the 2 to one side. 4, the 3 is going to go over, so you plus 4 plus 3 is a 7. 3 minus 2 is just x. So x is a 7. So you're going to throw 7 there. You see 2, throw a 7 there. This is like 14 minus 3. Your y value is an 11. You see. So again, the game is to not panic. Just be open-minded when you work out these kinds of questions. Now, the good news is you may be in grade 12 right now, but you're looking at some of these questions and you're like, oh, snap. Oh, snap, for real. They could easily ask this in like a metric paper, and they would expect you to know, because look, lo and behold, in grade 10, they still ask these kinds of things. Question 8 says, you receive a gift of 10,000 for your 21st birthday. Wow, nice. You deposit this sum into an account which earns 11% compounded annually, intending to withdraw the money after 6 years. Okay. So you deposit the money into an account. It earns interest. It earns 11% compounded annually. And then it says here, you intend to withdraw the money after 6 years. But it says here, after 2 years, you withdraw 2,000. And after 2 years, the bank changes the interest rate to 12% compounded annually. Okay. So in a situation like this one, they ask me to draw a timeline to illustrate this situation. So it's important to know how to draw a timeline, because you just need to keep track of events. So in the beginning, you received 10,000. So in the beginning, you have received 10,000. And then you deposit this into an account which earns 11% compounded annually, intending to withdraw the money after 6 years. Fine. However, 1 year passes, another year passes. So here they're saying after 2 years, you withdraw 2,000. So you minus 2,000. So from here, we need to keep in mind that they said here, right? You withdrew 2,000 after the first 2 years. And then it says here after another 2 years. So it means that 2 years pass. And then they said here after another 2 years, right? The bank changes the interest rate. So meaning 4 years passed with the same 11% interest rate. And then only towards the end here was the interest rate 12%, because that's what they said here. They said it's 11% compounded annually, intending to withdraw the money after 6 years. After 2 years, you withdraw money. And then after another 2 years, they change the interest. So this is your timeline. So with this timeline, let's see what they're asking. They say it here, calculate how much money will be, calculate how much money you'll be able to withdraw after 6 years. A question like this needs you to understand how the compound interest formula works. It says here, A is equal to P, 1 plus I to the power of N. So the idea is you need to be able to use the compound interest formula. The compound interest formula basically states that you're going to throw in a value here. It's going to gain interest over a certain period of time. So in the beginning, what happens is in your timeline, every time a change happens, you have to make a calculation and you have to keep track of that calculation. So a change is happening here, right? So we have to make a calculation there, and then a change is happening here. We have to perform another calculation there. And then a third one will be the final thing that will be giving us the final answer. So in your calculation, the way you write it out, it needs to be keeping track of what is happening. So this is what I mean. This is how you're going to do it. In the beginning, 10,000 is invested, you see. So you put 10,000 here as a value of P. That 10,000, we're dealing with it for the first 2 years. Remember, you deal with calculations only until a change has happened. So in the first 2 years here, your money is gaining interest, you see. So 1 plus, the interest is 11%, and it's gaining that interest over 2 years. There you go. So this is what you have after the 2 years. This is what you have in the account. This amount that you have in the account, you remove 2,000. So 2,000 is gone. Take note of the brackets. You have this amount after 2 years, and then you remove 2,000. After removing this 2,000, you then leave it for another 2 years while it is gaining interest. So this time when you're going to be leaving it for another 2 years, it's just going to be gaining interest, right? So it's your new P value. You're going to leave it for these 2 years here. You're reinvesting it. So this here is your new P value. You're reinvesting it, right? You're investing it for 2 years. The interest rate is still 11%. 11%. Now, what we do know is that it is also over 2 years. There you go. Now, when these 2 years have passed, your interest rate is now changing, you see. So when that interest rate is about to change, you still have your money in your account, you see. So you reinvest it again. This is now your P value. And then you're investing it for 2 years. 1 plus 12% now to the power of 2. There we go. So the fortunate thing is this entire calculation is something that you're able to put in your calculator. You're able to just put it nicely in your calculator with all its brackets. So let's see what that gives us. This amount, everything in our calculator, let's see what it gives us. It is giving us here 15,951.5. If you round it up to 2 decimal places, it's going to be 5.8. This was not a very, very good investment, like a whole 6 years, and it's just 5K interest. Terrible. But anyways, each to their own. Let us move on. Question number 9. Here we are. It says here, they're giving us formulas, which is nice. They also give you these formulas in grade 12. So only, no, they don't. They only give you the addition rule. But this formula here, I mean, this is just universal. This one is specifically for independent events. But they said, yeah, formula you may find useful for this question. 2 events, event M and N. They said, consider the Venn diagram above and use it to determine the following. So you have to remember, this is saying event M, right? There's the chance of event M happening on its own is 33 out of a total of everything. The chances of N happening on its own is 20 out of the total of everything. The chances of M and N happening together is 12 out of the total of everything. The chances of nothing happening is 15 out of everything. But let's start. The probability of M, right? This refers to everything to do with M. The probability of M is going to be the 33 plus the 12 divided by everything. So everything is 33 plus 12, right? Plus 20 plus 15. There you go. Now this, if you simplify it, you are going to get the following. That's what we get in our calculator here. Because in the calculator, you just have to make sure that you put in everything as best as you can. So at the top, we can see it's just going to give us a 45. At the bottom, 45 plus that, that's 65 plus that, that's give you 80. Obviously, you can simplify. 9 goes into, wow, it's kind of weird how 9 goes into what you call, 9 goes in here. I mean, 5 goes into each of them. 5 goes in there 9 times, 5 goes down there 16 times. There you go. Now this means or. This is asking the probability of M or N. When they ask for the probability of something or something, firstly, the probability of M would be all this. And then the probability of N, if they say the probability of M or N, what you do is you consider everything where M is, you consider everything where N is. You see? So here you're going to have the 33 plus 12 plus the 20. 33 plus the 12 plus the 20, the whole thing over 80. You see? So all this being done, you have 33 plus 12, which is 45, plus 20, which is 65. And then, now this you can just simplify it. The number that can go into both of them is obviously, again, just 5. 5 goes into 65 13 times, and then it goes into that one 16 times. There we go. For the bottom, it's asking what is the probability of M and N. You see? So the thing is, you have to keep in mind that and is inclusive. So this is asking where M and N meet, which is specifically just the 12. You see? That's the only part where you see M and N. So this is going to be a 12 over 80. 2 can go into both of these numbers. So you can have 6 over 40. No, you can go further here. 2 can still go in here. So it's going to be 3 and 20. There we go. 4 can go into each of these, actually. So the smallest fraction there is just 3 out of 20. So let's see. B says M and N are independent or not. Justify your answer. This is where your theory comes in. For independent events, right? The probability of M and excuse me, the probability of n should be equal to the probability of m multiplied by the probability of n. That's for independent events. This equation has to balance. So we want to test it out. So let's just put like a question mark here. We want to test out if this equation balances out. So the probability of m and n, we have here 0. We have here 3 over 20. The probability of m, we have it as 9 over 16. The probability of n would be 32 over 80. So let's see here, 32 over 80. So in your calculator, you want to test it out and you want to see if it like balances out. If it does not balance out, it's not independent. So clearly it doesn't look like it's going to balance out. Like it just, it's really not, it's just not. In your calculator, these don't balance out. So here you can say, therefore, not independent. Independent. There we go. Fantastic. So since these events are not independent, you can just move on to the next question, because if they're independent, these have to balance out. Question 10. Question 10. It says the following graphs are given. You have a parabola, a negative parabola, and you have a straight line. So the straight line, you're given no equation. The parabola, you're given an equation. The thing with our parabola is that they have given us the y-intercept, which is a positive 4. That's obviously useful. And then now, excuse me, let's see. 1 mark, they said, explain why Q is a 6 if A is 2 units above B. So you see why we need to know why this is a 4. They said, explain why Q is a 6 if A is 2 units above B. So you firstly have to know what Q is. You see, Q is the y-intercept of the straight line graph. What you also then need to know is that this is also the y-intercept of the parabola. So if they're telling us that A is 2 units above B, it means that if this is a 4, this has to be a 6, you see. So the only way you're going to tell them you know that this is a 6 is if you can tell them that this is the y-intercept of G and this is also the y-intercept of F. So you can say here, the y-intercept of F, the y-intercept of F is 4. And then here you can say Q, full stop. Q is the y-intercept of the graph of G. That is the reason why this is a 6, because if this is a y-intercept and this is a y-intercept, 2 up is just going to give you a 6. So nothing major there. So let's move on. Here this says, hence show that A is a -2 if D is 1 unit to the left of C. So D is 1 unit. Whoa. If D is 1 unit to the right of C. Really, how did I read left when it was saying right? Wow, that's just so weird, like proper weird. But anyways, yeah, they said here, do.
As of this recording, the All Access Pass, which allows you to access everything on the website, is currently on sale. The sale will give you access to the online courses for a total of 60 days. Now, the All Access Pass includes the entire syllabus, everything for paper 1, everything for paper 2, You have video lessons that are preloaded on the website, meaning that you'll be able to go through all these video lessons at your own pace, at your own time, without worrying about anyone necessarily scheduling any sessions. Now, the link in the description will take you to the course website where you'll be able to make a purchase of this bundle. The sale is ongoing between the 23rd of October until the 7th of November. Depending on when you're watching this, I suggest that you hop onto the course website and make a purchase. You can purchase directly on the website using a credit card, debit card, or you can make a purchase via the EFT details that are provided on the website. As a reference, you should put in your name and your surname and send the proof of payment to the email address listed on the screen. For more queries, questions, you can always just contact us via WhatsApp. If you would like to find out more information about Bright Young Brains, you can always just Google us and you will be able to find more information regarding what it is that you would want to find out. Depending on where you're currently residing, you can always just contact us via the contact details that you see on the screen.
Is 1 unit to the right of C, which is okay. So for 2 marks, before you can happily get your 2 marks, what they're trying to say is, if you're going to get A, remember A is going to give you the gradient of your straight line graph. Now, if you're going to get the gradient of your straight line graph, you at least need 2 coordinates to put into your gradient formula, because your gradient formula, A is the gradient, right? So your gradient is just y2 minus y1, x2 minus x1. You need 2 coordinates. So here you already have at least 1 coordinate. You see x1, y1. What are those? It's just x is 0, y is 6. Down here, right? What you know is that firstly, you don't have an x value, you only have the y value here, which is 0. For you to get the x value, you clearly now need to make use of C, because the moment you find C, you can just add 1 unit, you get the D. So to get the x value of C, you need to make use of your equation of F. See, your equation of F can get you the x-intercepts. It will get you E, it will get you C. To get the x-intercepts, you have to make y as 0. You see, so in this equation, you're going to make y as 0, and then you're going to have here minus x squared plus 4. And then the negative x squared goes to the left, and then you just have to square root both sides. This is going to give you plus or minus 2. That's your x. So here, you're going to put a minus 2. Here, you're going to put a plus 2. So in a situation like this one, you can clearly see that D automatically has to be a 3. So the moment you at least have the value of D now, it's easy to get your gradient, you see, because your gradient is just going to be, you can say here y2 and no, x2 and y2. So you can say 0 minus 6. And then here you can say 3 minus 0. Negative 6 over 3. That's a negative 6 divided by 3 is a negative 2. And there you go. You get your marks. So all this that we've done here, we can bring it nicely over here, showcase it over here, change the style maybe so that it pops. You need to choose maybe like a purple there. Whoa, bro, come on, we can't even see. Make this a bit bigger. There we go. Moving on. Now they want us to get the length of FD. Getting the length of FD, you see, this is where your theory or your sketch, you have to make use of your sketch nicely. These kinds of questions, they help you to see that your shapes and your Cartesian plane, they all work together. So if you look at it nicely, where D is, right, and where F is, you can even just use the distance formula to get FD. But for you to get FD, you need to make use of information on your sketch. So to get the distance of FD, you need both coordinates. The issue with F is you only have one of the coordinates, which is the X value. Remember, if the X value here is a -2, up here, it's automatically going to be a -2. Now you may be asking, how do we know it's a -2 up there? You have to remember, this is a sketch that's to scale, right? You don't want to overthink it. So you know that this X value is a -2. So to get the Y value of this point, you already know that you can just use the equation of your straight line. The equation of your straight line, you have it. You now have it. Remember, g of x is equal to -2. The value of q, we know it's a 6. So you have your equation nicely. Since you have your equation and you want the y value of f, you can just throw here a -2. You're going to have -2 with -2 here plus 6. And then you're going to have here +4 plus 6. This is a 10. There you go. So you now know that f is -2 and 10. Now you can get the distance of FD using the distance formula. You see, so the distance formula, you already know, you can just say the square root. You can start with the x's, x squared minus x1 plus the y2 minus y1 squared. And then here, it doesn't matter which ones you want to start with. You can just label it however you want to label it, but we're starting with the x's, right? So we can say here -2 minus 3, right? So it's going to be here like -2 minus 3. So let's just maybe make it like a red here. -2 minus 3, gonna square it. Then the y's, you can say 10 minus 0, and then you square it. So here, we're gonna have -2 minus -3, that's a -5 square. 10 squared, that's 100, you see. So you can see here we have -5 squared, right? Which is like 25. 10 squared is 100. Square root of 125 is our answer. Remember, 125 is not a square number. So you may want to just leave that the way it is. So in your calculator though, you're going to get the 5 square root of 5. If you go further, you're getting the 11.2 units. Let us keep moving forward. D says, determine for which values of x is this equation equal to 0? I mean, is this equation equal to 1? I'll repeat, determine the values of x. Determine for which values of x is g of x minus f of x equal to 1. What they mean is, you have to look at your graph and you have to look at where the distance between the y value of g and the y value of f, where is that distance equal to a 1? You see, that's what they're asking you. You have to look for where the distance between the y value of g and the y value of f is a 1. So to do that, I mean, you are going to need to work it out. Let's see what the mark allocation is. The mark allocation is a 3-mark question. So you may want to work this out algebraically, you see, because the distance here is like a 2. The distance there is like a 10. Somewhere here, the distance is going to be a 1, but you don't know. So you may want to just work this out algebraically. The equation of g of x, you know, it's -2x plus 6. You're minusing f of x, hence the brackets. Be careful of the brackets. So here it's like -x squared plus 4. So you have like -x squared plus 4. Close bracket equal to 1. So let's solve for x here. You're going to have your -2x plus 6. You can have plus x squared. And then you're going to have -4 equal to 1. And then here you're going to have the x squared, -2x. And then you're going to have the 6 minus 6 minus 4 is a 2. And then the 1 can come over. You can have 2 minus 1, which is like a plus 1. That is kind of crazy, but it works. Fortunately, here you can think to yourself, factors of 1 that give a 2. It's just 1 and 1. To get a minus 2, it has to be a minus 1 and a minus 1. And then this is x equal to 0. So fortunately, this is just x minus 1 is equal to 0 is your only option. It's the same bracket twice. So here you have the what do you have? X is a positive 1. You see. So here you're just going to say x is a positive 1. And visually, it does look as though like somewhere there, the distance between the two is a 1, which is how you work out these kinds of questions. You see, you don't overthink it. And you also just want to have a method and a system that you know works all the time. You see, so let's move on to question 11. Question number 11 says the following. An emergency flare is fired from a boat at B. Okay, so there's B here. An emergency flare is fired from a boat at B on a lake. And then it says the surface of the lake is shown as a horizontal dashed line. This is the lake, the surface. The flare comes from here, it goes up, going wherever. And then it says here, the flare's journey can be modeled by this equation. Clearly, this equation is an equation of an exponential graph. And then it says here where h is the height of the flare from the bottom of the lake in meters, and t is the time taken in seconds. So just keep in mind, this is just an exponential graph. So because this is a 10, which is going to be representing the asymptote of the exponential graph, it means here this is just a 10. And I mean, this would just represent an x-axis, this would just represent a y-axis. Just look at it exactly like that. So just because I'm using a real life scenario does not mean that your way of thinking when it comes to Cartesian planes changes. It does not. So here it says, what depth is the lake? So remember they said this is the surface of the lake, right? And then they said that h is the height of the flare from the bottom of the lake in meters. So they said here the flare is fired from B on a lake. The surface of the lake is shown as a horizontal dashed line. So this is the surface of the lake, and you see the bottom there is just down there where 0 would be. So when you ask for the depth, it's just 10 meters. You see, there we go. How high above the lake? How high above the lake surface was the flare fired? So you want to figure out the y value of B. The y value of B, remember, this is just an equation. This is just a what you call an equation, right? So if you want to find out the y value of B, you already know that here at B, the value at B here, the value for T, right, is a 0. So you're just going to throw a 0 in this equation, you see. So throwing a 0 in your equation there, you have 2 to the power of 0 plus 10. Anything to the power of 0 is a 1. And then you have a 11. So here you can say, therefore, at 11 meters above the, wait, if it's 11, this is 11 meters from the bottom. So if it's 11 meters from the bottom, it is only 1 meter from the surface, you see? At 1 meter from the surface. This is why these kinds of questions, you just have to be careful, because our equation gives us the height from the bottom. So if our height here from the bottom is an 11, it means from the surface itself, it's just 1, which is what they're asking. How high above the lake surface was the flare fired? It was just fired 1 meter above the lake surface. So let's keep things moving. It says here, after 5 seconds, the flare has ascended to height E. There you go, height E. And then they said, how high is this from the bottom of the lake? Well, the fortunate thing is they told us that it's after 5 seconds. So it's just a matter of putting 5 in the equation of H. The equation of H, we're going to throw a 5 there. 2 to the power of 5 is 32. This is giving us 42. Nothing crazy there. So this is also giving you the idea that you have to keep a calm head when you go through these kinds of questions. Keep a calm head. Here it says, how long after it is fired is it 8 meters above the lake? So 8 meters above the lake, you have to be careful now. It's not 8 meters above the bottom of the lake. This is referring to the surface. You see? Surface. Because if you look at the question, the way it's talking, right? They're saying here, how long after it is fired is it 8 meters above the lake? So you have to consider that if it is 8 meters above the lake, this would be 8, right? So our equation, we have to be careful to make use of 18, you see, because our equation only takes into account a distance from the bottom of the sea. So if you want to find out the time, right, where it is 8 meters above the lake, you have to put a distance of 18 in your formula, because your formula here for H, it takes the distance from the bottom. So you know that if this is 8, the distance from the bottom will be 18. So that's what you need to put there, and then you need to solve for T. You see, solving for T here, you're going to say 18. Let's go to 2 to the power of T plus 10. And just write this a bit better. Of T plus 10. This is a T here. 18 here. Now, the formula, remember, is H with T here, 2 to the power of T plus 10. Now here you can take the 10 to the left, you minus, so it's going to be 18 minus 10, which is 8. And we already know that the only thing that can give you an 8 is if you have a 3 as that exponent. So here, therefore, T is equal to 3. Wow, would you believe that? This test literally just ended out of nowhere. But you can see that your nature of your maths exams, right, it doesn't change. You have algebra, sequences and series, financial maths, probability, and then you have functions and graphs. In this case, we almost had a hint of applications of functions and graphs, which we know in grade 12 boils down to applications of calculus. So the big idea, as you can see with this paper and why I went through it, is I wanted to give you a wake-up call to say, don't leave your basics behind. Don't take it for granted that this is a grade 10 paper. Don't take it for granted that if you're in grade 12 and some of these questions were difficult, it means you really do need to do what you can to do better, you know? So that's why I always recommend the online courses on our website, because the online courses on our website, they're going to help you patch some of these gaps, you see, which is why I, for example, mentioned something like the algebra course is something that even a grade 10 learner can do, because that grade 10 learner needs to be able to answer questions like this. You see, they need to be able to answer questions like what we have here in section B. And we all know what section B looks like. You see, things like this, you need to be able to answer that. Things like this, you need to be able to think on your toes. You see, things like this, you need to be able to think on your toes. So I highly recommend that you sign up for the online courses on the website, depending on when you're watching this, right? Obviously, the online course main package, which is the all access pass, which gives you access to everything, it is currently on sale, right? The all access pass, there we go. You see, it gives you access to 17 courses all at the same time. It is currently on sale until the 7th of November. you see, and it's just going for 99 Rand. If you make a purchase, you get access to everything. The everything that you get access to is, you see, Euclidean geometry, functions and graphs, trigonometry, analytic. It's basically the entire syllabus, and it includes the NBT course, see. So you definitely want to take advantage of all this while it is still at your disposal. From my side, that is all that. You can see here, I was going through this paper because this is a paper that one of the students that I tutor privately is given. They got this paper as like a practice paper. So obviously, in terms of the sessions that we have, right, the deal was I go through the full paper, he also goes through the full paper, and then during our next session, he will at least have the link to this, and he will be able to like go through the different questions that are a bit tough. And then obviously when we do meet, he'll be able to like pinpoint out anything that we may have to just touch up on again. You get it? So that's the big idea behind why this paper is here. There will be more papers like this going forward, because I do think that whether in grade 10, 11, or 12, these papers are actually quite helpful. From my side, I will catch you in the next video.